Let us start lecture 27, and today's topic will be passivation and mixed potential theory. It is basically interaction of passivation and mixed potential theory. In the last lecture we have already started this, that interaction of cathodic polarization with the anodic polarization plots when the system goes into passivation mode. Now, we talked about active passive situation where the active portion of cathodic polarization line intersects this activation polarization part of a cathodic polarization line intersects the anodic polarization line in the active control region. Now, so our topic is passivation and mixed potential theory, and our subtopic for today would be effect of interaction of cathodic polarization at different sections or regions, I would say, of polarization plots of an active passive metal. So, this is situation we will consider. Now, in the last lecture at the end we talked about interaction of the situation where we can have active passive transition. So, this is my the active passive that metal which gives you active passive transition, where this is E equilibrium of metal, this is I 0 of metal over metal surface, and this is nothing but I A. And if the interaction happens with the cathodic polarization plot in the, we are talking about activation control mode. So, that means every interaction will be in the activation polarization part. So, if we consider one cathodic polarization plot, so this is my cathodic polarization plot, and here we have considered this is E equilibrium of hydrogen, and this is I 0 hydrogen over metal surface. Now, if the interaction is in this fashion, then this becomes my E core, which is nothing but E mix, at which I C, which is hydrogen, equal to I A, which is metal dissolution at this very location at the intersection point, and that is what we got a polarization plot like this. Now, when we leave that metal in an electrolyte, let us say acidic medium, the system will achieve this particular potential, because this is spontaneously achieved point where charge balance is maintained. And so, when we do polarization, we have to go with reference to this point, and we can go downwards with reference to this point, downwards, or we can go upward. Now, downside will have the plot, this plot will be visible when we do polarization, and the upside we will have this particular polarization, and this is happening as we have mentioned is a difference between two current. Okay. So, this difference when it is cathodic polarization or over voltage, cathodic over voltage, below less than E chord, and this is I A minus I C, which is anodic over voltage greater than E chord. Now, if we keep moving upward, then if we do take the difference between these two currents and then take log value of that difference, we will see a plot like this. The plot pattern would be like this. This will be the plot pattern. So, this, and we have seen that. Now, here system, if the system is left without having some external influence, here the external influence when you do polarization is the basically the either you give potential or current, but here if you do not do anything, it is a basically open circuit mode, the system will achieve this potential. But once you do polarization, the system will go downward as well as upward in the potential axis, and then you get different shapes of the graph, and here the shape becomes like this. This is log I and this is E, and the shape would be like this. This is the kind of shape we will achieve. Now, as we are seeing that in this particular case, if we leave it in the open circuit mode, the system will be at E chord in the potential log axis, and the current value would be I chord, which is this particular very point. Now, this is also similar to polarization between two active sides of cathode and anodic polarization, as we have seen in the previous when we have talked about interaction of active zones of two polarization plots, that is cathodic and anodic. But the situation would be different if we have a kind of intersection when we have a situation like this. If we have a situation like this, let us say this is log I and this is E volt, and if the cathodic polarization line moves like this, this is let us say hydrogen evolution, I am considering as my cathodic polarization, hydrogen equilibrium, this is I 0 hydrogen of metal surface, this is its activation polarization, which is N C equal to beta C log I C by I 0, and this is hydrogen. So, this particular line has this equation, this one. Now, if I try to see the anodic polarization plot, so this is going to be my anodic polarization plot. If this is my anodic polarization plot, which is this is E equilibrium of metal, I 0 metal over the metal surface. Now, we have to see the interactions between these two. One way that this line can cut here, another way that this line can cut here. Now, when this line cuts here, we have already seen how the graph appears if we do polarization. But if this line cuts at this position in the passive stable passive region or the steady state passive condition, where the rate of growth of oxide film is equal to the rate of dissolution, which is nothing but I p, that current density related to the passive zone. So, then what will be the shape of the curve? Now, in this case we are not initially if the position, relative position of this particular polarization, cathodic polarization plot is such that it is cutting like this. Instead of this, if it cuts here. So, this is the polarization plot, this is E equilibrium hydrogen, this is I 0 hydrogen over that metal surface. If it cuts there, now in the free on the when that open circuit condition, these two potential, this is the potential and this is the potential, these two potential, that means E equilibrium and E equilibrium M and E equilibrium hydrogen, these two potential would try to take the potential to this location. In order to satisfy mixed potential theory, which suggests that it should be E mix at which I c equal to I a. Now, if we see this, that means this particular potential will drag this potential upward, at the same time this potential will drag the potential downwards and it will come over there. So, up till this we will have cathodic polarization or cathodic over voltage, and from this if we compare, we will have anodic over voltage from the equilibrium or reversible potential. So, if we have this very situation, then in the open circuit condition the system will reach to this point, which corresponds to what? Corresponds to steady passive region. So, that means the E core would be, this would become my E core, and or it is nothing but E mix, and this particular corrosion current will be equal to I p. So, now what will be the plot? What will be the polarization plot? As we have understood that the polarization will be then with reference to E core. So, if we try to draw the polarization graph with reference to E core, and then we have to see the difference between two currents, that means current density rather, one is I c and one is I a as per this principle, and then this is the principle we have to adopt, and then we have to take log and then plot that particular log value with over voltage or absolute potential. Now, if we try to do that, the plot nature, because this is my I c and this becomes my I a. So, now it is the basically difference between these two currents, and since it is a log scale, so the plot would become like this. This will be the plot in this particular situation. Now, in this particular situation, in the free corrosion condition, this will be the potential, but once we have a forceful polarization, that time the applied this line is basically I applied line. In this case, this line is basically I applied line, or this is I applied line, and that I applied is basically the difference between these two currents and taking log. Here also it happens like this. So, what will be the nature of the plot? Nature of the plot would be nature plot would be like this. Now, when we do have this particular, situation, my corrosion rate would be, this would be my corrosion rate or IP, and that time we should not do like this particular operation. So, even if we do this, then we draw this and then extend this fat line, and that becomes my I core, okay. And then E core would be, this would be my E core. So, this will be the very plot nature. Now, in the, if we compare the plot what we have seen in the last in this particular situation. So, if we compare these two plots, one case the plot becomes like this, another case plot becomes like this. Now, in this case, we are having the mixed potential in the active zone of the in the active zone of the dissolving metal, because this is my active zone, fine. And if we go for polarization, then we can see this graph. So, here until unless we go and do the polarization and reach in this zone, we cannot achieve passivity. So, we have to forcefully take it to this region for attaining passivity, because this zone is the passive zone. So, that is what it is called active passive transition. But if we try to see this one in this case, without having any polarization, I can reach to this particular location, which is the passive location. So, that is what it is called spontaneous passivity, but here it is active passivity. So, this is active passive graph and this is spontaneous passive graph. So, this is the difference between these two situations, fine. Now, we can have another situation. This situation is basically in between these two positions. Now, if the interaction with the anodic polarization plot and cathodic polarization plot is in this fashion, let us draw that. So, if this is my anodic polarization plot, this is E equilibrium of metal, this is I 0 over metal surface of that metal, and if the interaction is like this. So, this is my I 0 hydrogen over that metal surface and this is E equilibrium hydrogen. In this case, now where I could see 3 points, this is one point, this is another point and this is another point, this is 1, 2, 3 points, I can have all 3 points, I can have 1, 2 as well as 3, all 3 points I can have this particular condition meeting. So, that means now where should I go? Okay, where in the free corrosion condition, where would it stay? Now, this is a tricky situation and this particular condition is actually can explain that why this zone is called unstable zone. So, when we see the anodic polarization plot, we have seen that this particular region is basically unstable zone, or this zone can be written as active passive transition or passive active transition. So, these zone, the influence of that zone will be coming into picture. In this zone actually we are not getting a stable passivity, rather steady state passivity is not obtained in this particular active passive zone. Rather we are, if we go from lower potential to higher potential, if we start from here, if we go there, then we will achieve stable passivity, or if we go. So, in this particular zone I am getting a kind of transition to steady state passivity. Now, when we are dipping that active passive metal into an acid medium, that time, and if it is a freshly prepared metal without having any oxide surface on that particular metal or hydroxide surface on that particular metal, the metal will be that potential. So, this potential and this potential, these two potential will try to drag those potentials downwards and upward to reach to that mixed potential position, and it is a freshly prepared fresh sample. So, freshly prepared sample, so where we do not have any pre-existing oxide layer. So, that case the system will try to find the first location where mixed potential theory is satisfied. So, that time the first location where mixed potential theory is satisfied is this location, where this becomes my E mix, and correspondingly I will get a situation like this where charge balance is maintained. Now, if this is my E mix, so accordingly the system will try to reach there, and then it will become steady over there. And then if we try to understand its polarization behavior, so I have to go downwards and then upwards from this location, that E mix location, and see the plot behavior. So, in this case again we have to do the same principle, that means I applied equal to I C minus I A, and then taking log of I applied with respect to the potential. So, the plot would become so this will be the plot. So, this will go like this and then come like this. So, the plot will be like this. So, how the plot looks like? So, this will be the plot. Now, this plot is appearing because this is my I applied, which is the difference between these two currents, and if we follow that principle we will get to this particular very polarization graph. So, the polarization graph, so if we see the plot, so if this becomes my E core, so I will have a plot like this. The plot becomes like this. So, that time this segment we call it cathodic loop, this segment. So, you have two I would say a peak in this particular graph I will get. So, this is the two loop I get, this is one loop, this is second loop I get. Now, what will be the now, if we see the influence of this active passive transition zone, let us say in one case the intersection is like this, and another case the intersection like this. So, both the cases, if we consider this to be, the slopes are same. So, this is the slope. So, I could see that cathodic loop appearance in both the situation would be one like this, the another case would be like this. So, I could see there could be variation in the cathodic loop. So, this red ink plot is basically the cathodic loop, and in both the cases this is E v log I, this is log I, and this potential. So, I could see that the cathodic loop pattern can change, and that gives us a kind of idea that how is basically the position between I p and this E p p. This point belongs to E p p and this point belongs to E c p. So, we can have an idea that how close they are situated. So, let us stop here and we will continue our discussion in our next lecture. So, we could see three situations when we have interaction between cathodic portion, cathodic polarization and anodic polarization of an active passive metal. In one case we get spontaneous passivity, another case we get active passive transition, and in another situation where the polarization plot of the cathodic portion cuts the anodic polarization plot in three locations, we get cathodic loop. And in case of cathodic loop, we do not get a proper passivity, because the system, if we start with a freshly prepared metal surface, it will stay in the active zone as we have seen, but if we have a kind of previously passivated sample, we could have a different situation. We will talk about those cases in our next lecture. Let us stop here. Thank you very much.